Alright guys, so now what we're going to do is we're going to do section 2. Our section 2 has to do with measuring simple harmonic motions. So let's go ahead and get into that. So when we're measuring simple harmonic motions, we're looking for three things. We're looking for amplitude, period, and frequency. Amplitude is the maximum displacement from the equilibrium. Period is the time that it takes to complete one cycle. And then frequency is the number of cycles vibrated per unit. So in the book, it actually gives you a term, an example, a definition, and an SI unit. I really like that one better. If I had saw it before, I would have done this one instead, because I think this is easier to understand the difference between the three of them. So amplitude is the displacement. Period is how it goes back and forth one complete cycle. Frequency, how many times it goes back and forth. Okay. So then we have as period is the same as of a simple pendulum in a simple harmonic motion, has to do with this math, which you have T, which stands for period, equals 2 pi square root of the length divided by the free fall acceleration. So we have a sample problem, and our sample problem says you need to know the height of a tower, but the darkness obscures the ceiling. You note that the pendulum extends from the ceiling, also touches the floor, and it has a period of 12 seconds. How tall is the tower? So we have the the time is 12 seconds. Gravity, of course, is 9.8, and now we're trying to find the length. To find the length, you would have to have the time squared times gravity divided by 4 pi r squared. So let's see what we have here. So if we do this, alpha y, enter, that would be open bracket 12, and we're going to do square. Whoops. And then 9.81, close, down, 4, and then we're going to do our pi, and then our square. And we're going to hit enter. And we get 35.78, which they got 36, which they rounded up. So question number 1 says, the period of a pendulum is the process sample problem of 24 seconds. How tall would the tower be? So we're basically doing the same thing here, except this time is 24. So the only thing we're doing here is we are also looking for the answer that it's trying to find. So we're going to do this time 9.81, open bracket, alpha y, enter, 24 seconds over 2 pi, and then, to blue. Here we go. And we're going to go over here, and I need to take that off. And then I'm going to close this, and then I'm going to square it because it tells me to square it at the end. And 9.81 times, whoops, I'm up here, which 143, but if I change my mode to scientific, I'm going to get 1.4 times 10 to the second. Number 2 says, you are designing a pendulum clock that has a period of 1.0 seconds. How long would the pendulum be? So we're going to do it this time. We're going to say, all right, there's 1.0 seconds. Gravity's 9.8, and we're looking for the length again. To be able to do that, we're going to do 9.8 times 1.0 over 2 pi squared, and you should get 0.25 meters, which you need to change to 25 centimeters. And so then I feel like you got 3 and 4 are about the same. Period of the mass depends on the spring system, depends on the mass and the spring constant. So we have a period equals 2 pi square root of mass divided by the spring constant. We had a sample problem here. And in this sample problem, we had, it says you need to know the height of the tower, but the darkness obscures the ceiling. And so, whoops, I'm not on the right one, sorry. A large pearl was found in the Philippines in 1934. Suppose that the pearl is placed on a spring scale, whose spring scale constant is 362 newtons per meter. If the scale platform oscillates and has a frequency of 1.0 hertz, what is the mass of the pearl? So what we're going to be doing here is we're going to be doing alpha y inner, alpha y inner, and we're going to do 362 because that's our constant over 4, and we're going to do pi. We're going to do a square, but this time we're going to times 1.20 hertz, and we're also going to square it because that's giving us a frequency that we need to add, and that is 6.37 is my answer. Question number 1 says, a mass of a 0.30 kilogram is attached to a spring and is set into motion with a period of 0.24 seconds. What is the spring constant of the spring? So we have our 24 seconds, we have our 0.30 kilograms. So one thing we're going to do now is we're trying to find the constant. So we're going to do alpha y inner. We're going to do 4 pi square, and our mass is 0.30. And we're going to divide that by our time squared, which is 0.24. And I needed to square it because I don't think I did it over there. So let's go back up, hit enter. And I need to square that. And then I get 2.05, which is 2.1 times 10 to the 4th. So let me make sure that I put that on here because I didn't write it, but I did it. Okay, so number 2 says, on Halloween you see an alien that has one antenna made of glitter foam ball connected to a spring. The spring oscillates at a period of 0.079 seconds and has a spring constant of 63 newtons per meter. It's asking you find the mass of the ball. So for this one, we're going to do alpha y inner. We're going to do 63 times 0.079 seconds, and we're going to square that, and we're going to divide that by 4 pi, and we don't have a radius, so we're going to just do square, and we're going to hit enter, and we get 9.5 e negative 3. So where am I wrong at now? 63 times 0.0, oh, I didn't do, yep, 79 square divided by 4 pi square, and it should be 1.0. I got 9.95 times 10 to the negative 3. So I'll need to go back and check that answer. Number 3 says that a 125 Newton vibrates at a period of 3.56, was hanging on a spring. What is the spring constant? So what I'm going to do there is I'm going to do 4 pi square times 125 divided by 9.81 times 3.56 squared should give me 39.7. So let me go back here. 63.079 2 pi square. Let me try that one more time for this one. So alpha y inner, and so I have open bracket 63, did 62.079 square and 4 pi square inner. I'm still getting 9.95, so I'm going to go with my answer. I like the answer that I have because that's what I got twice. So I'm going to go ahead and write down this 9.95 times 10 to the third, or better yet 6, or if it's 9.96 negative 3. And I don't know how they got that answer, because that one does not agree with me. So, so this is the end of this day. So if you would turn in your one-pagers that you did, along with your math, so then now you have 2 of them that you need to turn in today, and go ahead and turn them in. And then tomorrow we're going to do the next 2 sections. We're going to continue to do the next 2 sections with the practice problems until the 15th. I hope you have a good day.